Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to continue our discussion of factoring. So we've already talked about how to factor using the greatest common factor, the GCF, and we talked about how to factor trinomials when the leading coefficient, or the a value, is equal to 1. Well, now today we're going to look at a couple of different examples and look at a slightly more challenging factoring method, but it can help us out in certain spots. We're going to skip the first page. That's just a little review of the type of factoring we did before with when a is equal to 1, factoring trinomials. And we're going to look at these two problems right here. So I'd encourage you to pause the video and see if you can factor both of these trinomials. Now, you'll notice the a is not equal to 1, right? There is a 4 instead of a 1 here and a 4 instead of a 1 here. But if you think back to some of the challenging problems from last lesson, can we use the GCF before we use our factor sum chart method? So GCF first. If we can get the a equal to 1, we can then use the factor sum chart. So pause video, give those ones a go, and then come back and join us for a discussion. Okay, so the GCF of the one on the left is 4. So I'm going to factor out a 4, which means I divide all of these terms by 4. That leaves me with x squared plus 7x plus 10. Now I can try to figure out how to factor this trinomial using a factor sum chart. Well, I'm going to draw my little factor sum chart. I'm looking for factors of 10 that sum or add to 7. I think this one's pretty straightforward. 5 and 2. 5 and 2 added together give us 7. So what I'm left with is 4, and then my two binomial factors are x plus 5 and x plus 2. So my final factorization is 4 times a quantity x plus 5 times a quantity x plus 2. So once we factored out that GCF, it became a little bit more straightforward for us. Maybe you tried the one on the right. If not, pause the video, give that a go. Greatest common factor here actually isn't 4, right? Because 18 is not divisible by 4. Greatest common factor here is 2. So we're going to factor out a 2. That gives me 2x squared plus 9x plus 10. Now, we can't use the factor sum chart here because the a value is 2. It's not 1. So the factor sum chart method is not going to work. So even though we could find and factor out a GCF, it did not make the a value 1. So we're kind of stuck, or at least we were stuck up until today. Today we're going to learn a way to factor something like this, where the a value is some number other than 1. Okay, let's go down and talk about how to do that. And at the end of the lesson, you could actually come up here and finish off that second problem. So like we discussed, sometimes you'll be given a trinomial where the leading coefficient, that's just the a value, is not equal to 1, and you will not be able to factor out a GCF such that that a value equals 1. Well, today we're going to learn a method to handle these situations. So let's jump into this example right here. Here, our a value is 6. So this method is called the AC method. Why is it called the AC method? Well, remember when I told you what the general form of a trinomial looked like? Ax squared plus bx plus c. Well, the first thing we're going to do for the AC method is multiply a times c. So in this case, we get 6 times 4, which gives us 24. Once we multiply a times c, we are then going to use the factor sum chart, just like we did for when a is equal to 1. So I'm going to do that over here. Now the difference is I'm finding factors of AC that add to b. I'm not finding factors of just c. So in this case, I'd be finding factors of 24 that add to 11. So the only difference here when your a value is not equal to 1 is that you're finding factors of a times c that sum to b. Well, we could try 6 and 4. That equals 10, though. We could do 12 and 2. That's going to sum to 14. How about 8 and 3? 8 and 3 sum to 11, so we're going to work with those. Now again, it doesn't mean we just do x plus 8 times the quantity x plus 3. That's not going to work. It's not going to be any good. We've got some extra steps here. What I'm going to do is once I find those factors, I'm going to rewrite my trinomial. And actually, I'm going to make it a 4-term polynomial. So it's going to be 6x squared plus 8x plus 3x plus 4. Now, if you think about it, right, this is equal to what I have in green. All I've done is break up my middle term. Now, I could break that middle term up in many different ways, right? Because I could have 10x's and 1x. I could have 5x's and 6x, etc. However, the whole purpose of doing this factor sum chart was to find the specific way to break that middle term up. We need to break it up into 8x's and 3x's for the rest of this factoring to work out properly. Okay, so you can't just randomly break it up. You have to go through that factor sum chart to figure out the exact factors to use to break that middle term up. Once I have it broken up, I then do something called factor by grouping. And what that means is I group these two sets of terms together. Now, I find the greatest common factor of each of those sets of parentheses. Well, for the first set, greatest common factor is 2x. And you could think about it, if I divide each of these by 2x, I'm going to get 3x plus 4. Now, if I think about the greatest common factor for my second set of parentheses, it's actually just 1. The 3 and the 4, well, those don't share any other factors other than 1. And there's only an x next to the 3. So there's no x's next to the 4, so x cannot be part of our greatest common factor. So I factor out the 1, and I'm just left with the 3x plus 4, right? Because if I factor out a 1, if I divide both of these by 1, I'm left with what I started with. That's okay, though. We can, if we have to, we can just factor out a 1. Now, what you'll notice is that we should end up, if we do this properly, with the same thing inside of parentheses, which is neat because it allows us to factor one more time. If I think of both of these terms or quantities, right, if I think of both of these sets of factors as a single term, well, what do they both share? Let me rephrase that. Both of them together are not a single term. We're just thinking of the red as an entire quantity and of the pink as an entire quantity. Well, what do the red and the pink share? Well, they both share that 3x plus 4. So if I factor out a 3x plus 4, if I factor that out from the red, I'm left with 2x. If I factor it out from the pink, I'm just left with positive 1. This right here is the factorization of this trinomial. Now, this is a significant amount more, this is a significant more amount of work than the previous factoring method we used, right, where we just did this factor sum chart, right? Here we've got to multiply a times c, do the factor sum chart, we've got to factor by grouping, and there's just a lot of moving pieces here. So I don't expect you to understand it after one example. We're going to do, a couple more. But, it's very important to stay organized throughout this process, right? Because there are several different steps that we need to hit if we're going to get to the final answer. Let's try another one. But I'd like you all to pause the video and see if you can apply the steps we just did to this new trinomial. And you may get stuck at some point, that's okay, but give it a go and then join us back in the video for a discussion. All right, so if you remember, this is called the AC method. And we call it the AC method because we multiply the A and the C together. This 10 is A, this 3 is C. So A times C is equal to 10 times 3, which is equal to 30. Now, we're going to find factors of AC, so factors of 30, that sum to B, so that sum to 17. So factors of 30, 15 and 2. And you know what? We got it the first time. So there's no need to write down any more factors because we chose the right ones the first time. Now we take these factors, right? And these factors are what tell us how to break this middle term apart. Right? So we're going to have the 10x squared and we're going to have the plus 3. But we need to figure out what to split the 17x into. Well, the factors are 15 and 2, so I get plus 15x plus 2x plus 3. Now you may say, Mr. Fawcett, can I switch these? I sure can. And the rest of your work may look a little different, but your final answer is going to be the same. So if you want to flip those factors, that's okay. As I say factors, they're not being multiplied together, they're being added, but the 15 and the 2 are the factors we found. So you can flip those, it still comes out to be the same. Maybe we'll actually do it, the opposite way over here, just so you can see that our final answer will be the same. So I'll put my 2x first here, my 15x second, and we'll just do it side by side. Remember, now I'm going to factor by grouping. So I'm going to put parentheses around the first two terms and the last two terms. And I'm going to find the greatest common factor. I'm going to start with the orange. The greatest common factor of the first set of the orange parentheses is 5x. If I divide 10x squared by 5x, I get 2x. If I divide 15x by 5x, I get 3. Now, if I look at this second set of parentheses, the greatest common factor here is just 1. So I'm just going to have a 1 on the outside, and the inside is going to stay the same, because if I divide 2x by 1, I get 2x. If I divide 3 by 1, I get 3. Now my final step, right, is to factor one more time. So both of these quantities here, both of these products, because they're what I have in green are two factors that are being multiplied together, they both share a 2x plus 3. So if I factor out the 2x plus 3 from both, I'm left with 5x from my first quantity over here, my first product, and then I'm left with 1 from my second product. So the factorization is the quantity 2x plus 3 times the quantity 5x plus 1. Okay, let's go ahead and do the green on the other side, just to see if we get the same thing. The greatest common factor of our first set of parentheses here is 2x this time, which means I'm left with 5x plus 1. Greatest common factor of my second set is actually 3. I do have a greatest common factor here. And if I factor out a 3, I get 5x plus 1 inside. Now you'll notice that these products, well, they share a 5x plus 1. So I factor out the 5x plus 1, and I'm left with 2x from my first product and 3 from my second product. And you'll notice that we get the same factorization. It doesn't matter that the factors are flipped. When we multiply those together, when we distribute, we would get the same thing. So a couple different ways you can do these problems, but final answers should look alike. All right, I'd like to show you one more example. this time where our middle term is going to have some negative pieces to it. Let's do this top one right here. All right, so again, I pause the video, try it on your own, of course, and then come back and see how much of it you did correctly. Okay, so a times c, 2 is our a, negative 21 is our c, make sure you include that negative sign. A times c, a is 2, c is negative 21, so this gives me negative 42. So when I set up my factor sum chart, I want to find factors of negative 42 that sum to 1. 1 is my b value, right? It's not written there, but we can consider it 1 because it's 1x. Now we need to think of factors of 42. And if it's negative, if 42 is negative, well, we're going to have one negative factor, one positive factor. And they need to be close together because the difference is 1. So let's try negative 7, positive 6. Those multiply to negative 42. They add or sum to negative 1. So that doesn't work, but we're close. Oh, let's flip the sign. So let's do 7 and negative 6. Well, that's going to sum to positive 1, which is what we want. So now we're going to rewrite this trinomial. So I'm going to get 2x squared. Again, it doesn't matter what order we do it in, so I'm going to do plus 7x minus 6x minus 21. Okay, now we've got to separate these into two sets of parentheses. So I've got my first set right here. Now, this is where it gets a little tricky. I need to put my parentheses around this negative sign. I need to include the negative with the 6x. And I'm just going to put a plus in between, right? Because I'm not multiplying those parentheses together. I am adding what's inside the parentheses. And if you're thinking, well, why am I allowed to do that? Well, let's think about this. If I do 6 minus 3, isn't that the same thing as 6 plus negative 3? Right? 6 minus 3 is 3. 6 plus negative 3 is still 3. So if I include the negative in the set of parentheses, that's what we need to do. I just need to put an addition sign in between the parentheses so I know that I'm not multiplying, right? I'm adding those sets of parentheses together. Let's go ahead and find the greatest common factors. For the first set of parentheses, greatest common factor is just x, because those numbers 2 and 7, the greatest number that they share is 1. So we could say 1x, or we could just say x. Doesn't matter, I'm just going to go with the x. When I factor out the x from 2x squared, I get 2x. When I factor out x from 7, I get plus 7. Okay. I then have plus out in front here. And if I think about the greatest common factor of negative 6 and negative 21, well, it's 3. But I'm going to factor out a negative 3, not a positive 3. And you'll see why in a second. Well, actually, let me do it. Let me just factor out a positive 3, and we'll see what happens. So if I factor out a positive 3, inside I'm going to get negative 2x minus 7. Now, the only problem is I need these inside to match, right? I need them to be exactly the same so I can continue my factoring process. Well, factoring out of 3 did not make those the same. Let's see what happens when I factor out a negative 3, though. So negative 3, if I divide negative 6x by negative 3, that's going to give me positive 2x. Negative 21 divided by negative 3 gives me positive 3. So factoring out the negative version of the greatest common factor will make the inside exactly the same as what we have over on the other side, and that's what we want. You could rewrite this without having the plus minus in the middle, so I could do x times the quantity 2x plus 7 minus 3 times the quantity 2x plus 3. Again, just getting rid of that plus sign because it means the same thing now. And both of these products they share 2x. Well, you know what? I just realized I made a mistake here. It should be plus 7, right? Plus 7 and plus 7. Now it's correct. When I factor out the 2x plus 7, well, I'm just left with x for my first product, and then I'm left with -3 in my second. So the correct factorization here is the quantity 2x plus 7 times the quantity x minus 3. Okay, you're going to have plenty of time. You're going to have plenty of problems to practice this method on. It's not one that you're going to probably get right away because there's more nuances to this method than there are the other factoring methods we've used. So just keep being persistent with it. Eventually, it'll start to click, and it won't feel like you're trying to memorize, a bunch of different steps. It'll just start to come more naturally. But it is more complicated than what we've done before. We are going to stop the video there. I think we've gone far enough. As always, enjoy the rest of your day, and I will look forward to seeing you next time.